channel. Today we will solve combination sum problem and we will write the code for this problem in C++ as well as Python at the end of this towards the end of this video. So let's go through the problem statement. So given an array of distinct integers. So we have distinct integers in the array and the array name is candidates and the target integer target is given. Now what we have to do, we have to return a list of all unique combinations. So unique combinations of candidates where the chosen number sum to target. You may return the combinations in any order. So output can be in any order. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. So basically we can select any number from the given candidates array any number of times, but we will consider it as a unique combination when we do not have any other combination with having the same frequency of those numbers which we are having in the current combination. Like for example, we have here, we'll go through this example. So candidates is equal to 2367 and target is 7. So basically we have to find the elements in sorry, in candidates array whose sum is equal to target. So let's begin with the first element 2. Let's add it one more time, or let's go through this output which it is whichever what is given here. So here first combination which is given is 2 comma 2 comma 3. So 2 plus 2 4, 4 plus 3 7. So that sum of this combination is equal to 7, and the next combination which they have given is 7. So the sum of 7 is equal to 7. I mean, it's obvious. So the explanation is 2 and 3 are candidates and 2 plus 2 plus 3 equal to 7. Note that 2 can be used multiple times. So we have used 2 multiple times. That doesn't matter. But this 2 comma 2 comma 3, this combination or this combination, this should appear exactly once. I mean, it should be unique. So that is what the question is asking. So this was first example. Another example is 2 3 5. So we have these combinations 2 2 2 2. Sum is 8, which is equal to target. And for 2 3 3 also sum is 8, and which is equal to target. 3 plus 5 equal to 8. So these are the examples. Now let's see the constraints. So constraints is 1 is less than equal to candidate's length less than equal to 30. It means that there can be maximum 30 elements in the candidates array, right? Maximum 30 elements. The length of the candidates can be maximum 30 and minimum 1. So at least one element will be there. And next constant is 2 is less than equal to candidates I is less than equal to 40. It means that the value of any element in the candidates array will be in the range of 2 and 40, like greater than equal to 2 and less than equal to 40. All elements of candidates are distinct. Okay, so we do not have duplicate elements in candidates array, and 1 is less than equal to target is less than equal to 40. So it means that the value of the target ranges between 1 and 40. So so we are clear that we do not have any negative elements in the candidates array and we do not have any negative value for the target. So that's cool. I mean, that makes the problem a bit simpler, and all the elements of candidates are distinct. That's fine. But we can use any element any number of times, like we are using 2 here, 2 times, right? So how will we go towards solving this? So l- I'll just open an Evernote for this. So this, suppose this is the, we'll take this example given here, 2 3 6 7. So we are given set is 2 3 6 7, 2 3 6 7, and target is 7, right? So when we are iterating through this set, uh, so first let's discuss what are the different approaches we can take. So the brute force approach could be to consider each combination each combination of elements from this set S, right? List them down, like for example 2 2 2 2. We will list all the combinations until and unless its sum becomes greater than target, right? So 2 3 3 3, some so on and so forth, 2 3 6 6. So there can be many combinations, right? Because we can repeat the elements, right? We can have 3 n number of times, 3 3 3 6 6, like that, 7. So if we do all that, and then after that if we check the sum of each subset, and if it is greater than, sorry, if it is equal to target, we uh, store it in the output vector. Suppose we have an output vector where we store the combinations whose sum is equal to 7, right? So this will not be a good approach, but good, it's good to start with. It's a brute force approach, that we are considering all the combinations, different combinations of these elements given in the set S, and after that we are iterating over each combination, checking whether its sum is equal to target or not. The summation of the elements is equal to target or not. So, but this is not an optimized approach. Why? Because first we will list down all the combinations, and then we will iterate through each combination, find the sum of each combination, and then put them in the output vector if the summation of the combination is equal to the target which is given. So this was the first approach, which is actually not optimized, and it may lead to multiple errors also if not done carefully. The second approach would be, like, we will take different combinations, like take different combinations from the set S, and every time we will see if the current summation is equal to the given target or not, right? And at every point in every iteration, we will have the option to either select the current element and put it in our combination or not. So what do I mean is, let's consider the approach of recursion to solve this. So we have 2, 3, 6, 7, right? And we are currently at index 0, and our combination which we have created till now is empty, right? So we are at index 0. This is 0 1 2 3. Now we have the option to either include this 2 in our combination or exclude it. Like if we include this, then what we'll have in our combination? Our combination will have 2, right? And index will go to the next index equal to 1. And if we exclude this, will anyhow, sorry, just ignore this, index will be still 0. I will explain it why it is 0. Index will become 1 and combination will be empty as it is, right? Because we are excluding 2. And now when we include this, we have the option to again include this 2, right? Why? Because we can repeat or take an element any number of times, n number of times. So we need not move forward. Like we can include this 2 again here. So if we include this 2 again, index will be 0 and combination will be 2 comma 2, right? And if we exclude this, index will be 1 and combination will be 2, right? Again here, like, if let me scroll down a bit. Again here, if we include 2, again index will be 0 and combination will be 2 comma 2 comma 2, right? And if we exclude 2, our index will be 1 and combination will be 2 comma 2, right? So this is how we'll move forward. But when will we stop here? When will we stop our recursion? Right? That is something we need to think about. But before that, let me explain the excluding part. Like when we here, one branch is to include this two, first two, and second is to exclude this two. So when we are excluding this, then we will increment the index. If we are including, we will keep the index as it is. Here also we are including, this index is same as this. This index is same as this, right? And again here we included, this index is same as this, right? So here index is equal to 1 if we include this element which is there at index 1, that is 3. If we include this, index will remain same. Why? Because we can again include this 3 in our solution. So combination will become 2 comma 2 comma 3 and index will be 1. And if we exclude this, index, we will increment the index. Index will become 2, right? 1 plus 1 is 2 and combination will be 2 comma 2 only. Whatever the combination is here, same if we are excluding. Now understand, when will we stop, right? When will we stop our recursion tree? So one criteria, which is the simplest criteria, is when to stop recursion. Let me write it. First criteria is when a current index or the index becomes equal to the size of set or the given array, set or list, whatever, right? This is one condition. Second condition is when sum of combination becomes equal to target. So as soon as the sum becomes target, equal to target, like for example here combination, sum of this combination is 2 plus 2 plus 3, that is equal to 7, which is equal to the target which was given in the question. So we will not move forward. Why? We will not include anything, because if we include, that sum will become greater than target and it cannot become less in the future. Like if we keep doing the recursion, the sum will not become less, right? It will keep increasing. So there is no need to do further recursion once the sum of the combination becomes target, right? This is second condition. And third condition is when sum of combination is becomes greater than target, right? Why this is so? This is because suppose the sum has already become already become greater than target. What will happen then? It cannot go, we cannot reduce the sum any further, right? For let me just give an example to explain that. Suppose here we are doing 2 plus suppose, let's take this element. So suppose after excluding 2, 3, 6, 7, now we have the option to either include or exclude 7, correct? Right? Either include or exclude 7. Assume that, assume that 2, 3, 6, 7 is there. Suppose we have excluded 2, excluded 3, we don't want this in our combination. Now we include this 6, suppose. Include this 6. Our index is what? 0, 1, 2, 3. So if we include this, index will be same as before, sorry, say 2, which is same as before, and combination will become what? 6. Now we have again option to include this element. So again if we include this, index will be 2 only, right? And combination will become what? 6 comma 6. 6 plus 6 is 12, which is greater than the target which is given to us. So if we keep on doing our recursion, like if we again include 6, then index equal to 2, combination equal to 6 comma 6 comma 6, right? So sum will become 8, sorry, 18. Sum will become 18, which is greater than 7, which is the target given to us. So sum will keep increasing. So why are we doing this recursion, right? It will become infinite, it will become endless. So we have to stop it where the sum has become greater than the target which is given to us. So if sum is greater than target, just stop the recursion there itself. So that is the third condition. And Second condition is somewhat special as compared to first and third. In the second condition, if sum of combination is equal to target, then the current combination which we have got, we will insert that combination in our output vector or list. Okay, insert this whatever combination we have got whose sum is equal to target, we will insert that combination in the output vector or list, which has to be returned, which has to be returned, right, or printed. So basically, which is our answer, right? Returned or printed, whatever is given in the question. So this is the entire logic. Hope you have understood it. If you didn't understand, you can just mention in the comment section. So now I think we are fine to go ahead with the code, right? So we'll go to the lead code platform for writing the code for this. First we'll write in C++ and then we'll write the Python code. So what is given to us? A class solution, a function, vector of int. This is the return type, so we have to return a vector of int. This is the function name combination sum, and what are the parameters do we have here? Candidates and target. So candidates is the given array, right? And target is the given target sum. So first we will define the output vector of vectors that we have to return from this function, and I'll just return OP. So this is you can up, mm, follow any approach. So I have just first thing which I do is just create the variable which has to be returned and write the return statement so that I do not forget to write the return statement later. So this is our output vector, and let's create the combination vector. So this com vector will contain our current combination int sum, say equal to 0, right? This is the sum of the current combination, and int current x is equal to 0, right? So this is the current index, and the current index will be always 0 because we are starting from the 0th index, right? And then we have to call the recursive function and pass all these parameters. So let's name it, say, find sum or something, find sum, and pass the given candidates comb op target sum and current index, right? And we have to define this function here. So void find sum vector int and candidates. So why do we have a void return type here? Because we will store the output in the OP vector only. So we need not return anything from this find sum recursive function, right? So we will store the output, keep storing the output, keep appending the output to our OP vector. So vector int and candidates, this is our first parameter, then vector int and comb vector int and OP. So we are passing the address here so that we do not make copies of these variables. It will help in two ways. One, we will not consume so much of extra space by creating the copies of these and OP vectors continuously. And second thing is, we will keep inserting our combination vectors um, in the single and the only one instance of the OP vector. So we'll just have one instance of OP vector where we will keep inserting the com vector. Otherwise, if we don't pass it by reference, right? If we pass it by value, then we will create multiple copies and that will not give us the correct answer. So let's just int target, right? Target int sum int current index. So we are done with the parameters. So what was our current first condition to break the recursion tree or stop the recursion tree? We'll write the combination, sorry, conditions later. First we will write the logic. First step would be to include the current element in combination, right? In combination. So what do we have here? Find sum. If we include it, then we have to push it in our comb vector, right? And then find some candidates comb op target. So some also we will increase, right? Because we are adding this current element in our combination. So we have to add that value in the sum also. So sum is basically the current sum of the combination. So we'll add this value to sum and we will keep the current index as it is because we can again include this element in the next recursive function call, right? So that is why we are not incrementing the current index here. Now after calling this recursive function, we will pop the current element which we had inserted in the combination. Why? Because this is backtracking so that later on it doesn't create any issue. Like whatever changes we have done in the comp, we will just make it back to the original form. This is called backtracking and it will help because suppose we have included two ones and again in the next recursive function we want to exclude two. Sorry, we want to have a fresh combination starting from three, right? That can be one of the possibilities. So we can achieve that only when we have popped two from the combination. So that is the whole idea um, of popping back. So you can learn more about backtracking on the internet, or you can comment in the comment section if you want me to make videos on backtracking. So we'll move forward with our logic. So first, this is the include current element in combination. Second would be exclude current element from the combination. So here what we will do, I'll just copy this. So we will not include the current element in our combination. We'll just call the recursive function and will not change our sum value and just increment the current index. Since we are excluding this current element, we do not want to exclude it, sorry, include it in the future also. So we will just increment the current index. So now we'll write the conditions to stop the recursion tree. So the first condition would be if sum is equal to target, then insert the current combination in our output vector, right? Then return. If sum is greater than target, right? We saw that if sum becomes greater than target, then we cannot ever achieve uh, sum is equal to target, right? If once it exceeds the target, it cannot go down. It will keep increasing because we have positive integers in the candidates array. So the sum will keep on increasing. So whenever sum becomes target at any point, we'll just stop the recursion call. We'll just return from here. So this is another condition. The third condition would be if curIndex becomes equal to candidates dot size. So whenever the current index becomes equal to the size of the candidates array, that is we exhaust parsing, we exhaust all the elements of the candidates, that is we passed through all the elements of the candidates, so we'll just return from there. So this is our code. Let's see, let's run it and see whether we are getting the correct answer or not. So this is accepted. Now let's submit this. Yeah, so this is accepted. Now we'll go back and we'll write the Python code for this. So we have def combination self candidates of type list int target int, and we have to return what? List of int. Okay, awesome. So we have this. So suppose then let's create the output list, right? This is the output list and this is the comb list, and cur index will be 0. Sum will be initially 0, right? Sum is getting highlighted, so let's I just rename it sum com equal to 0. Probably it was a sum is a uh, is not a it cannot be an identifier in Python. It's a token, I think. Not token. I mean a reserved keyword. Yeah, it must be a keyword. So that's why I renamed it to sumcom. Sumcom equal to 0. Now what else do we want here? I think yeah, target we are given. So let's call the and we have to return what? OP. Now let's call the recursive function. Pass all the parameters. P target sumcom and cur index, right? And let's write the wait, def find sum. We are writing the recursive function right now. Self candidates target, not target. We will need comb here. Com op target sum com and cur index. So first condition is if sum com is equal to target, then op dot append com dot copy. So com dot copy is used to create the copy of the comb list. We need it because otherwise if we just append, append doesn't exactly appends the list. It will not exactly append the comb list. Basically it will point to the address of the comb, so that will give us incorrect answer. So that's why I'm making a copy of it here. You can read more about copy on the internet, or you can comment in the comment section. We can make another video on that. So if sum equal to sum comb equal to target, then return. So this is one condition. If sum comb is greater than target, then also return. If cur index is equal to len of candidates, then also return. Now what do we need to do? Yeah, first condition to, let's say, exclude the current element. If we have to exclude it, find some candidates com op target sumcom current index plus 1. We'll just increment the current index and leave everything as it is because we are excluding the current element and moving to the next element. So we'll just increment the current index by 1. Second subpart is to include the current element in combination list or com list. So we will just do an append com dot append candidates current index, wait, current index, and then call find sum with candidates com op target sum com plus candidates current current index, and we'll leave the current index as it is because we may need to include the current element once again, right? And after appending we will just pop it from the com list. So this looks fine. Only thing is I am a bit skeptical or doubtful about the syntax because I do not practice Python much. And let's see if we are not running into any syntax. Find sum is not defined. Okay, is it a typo or something? Find some candidates com op target sum com 1 2 3 4 5 6 3 4 5 6. This looks correct only, right? Find some. Okay, it's saying it's not defined. Okay, probably I cannot write this function. Probably lead code is not allowing me to write this function here. I'm not sure. Okay, okay, okay. Let's. Yeah, this is accepted. This is also accepted. Awesome. So thanks for watching this video. If you have any doubts, you can comment in the comment section. Please like the video and subscribe to my channel. Thank you so much.